Good morning, everyone.
Hello.
How are you, Radislav?
Morning. I'm perfectly fine. Thanks. And you?
Good, good. It's finally starting to get warm here, so that's nice.
We have absolutely the same in Poznan. Yesterday was terribly rainy. However, now the world is loaded with sun. Nice weather, really.
Very, very good. All right, so I think we're going to have fewer people today since it's the Vault conference this week in Boston, so a number of folks are out there. But let's get started anyway. So let's see. We have a lot of new pull requests this week. Big one is a cleanup of Igor's PR for, actually, that was based on an earlier PR, I think from Majian Peng, to separate the KV sync thread in Blue Store into two parts. And as we saw last week, based on Igor's slides, it looks like that has a pretty substantial impact on performance. So unfortunately, that is not compiling right now, at least in certain versions of GCC. Possibly it works in newer ones, but we need to clean that up a little bit more before we can start testing it. Let's see, there's been some ongoing zero copy work for RDMA in the async messenger. And there's a new one from Halmai there, and there should be, I think, a couple of additional ones coming. Let's see, a couple of other random ones here I haven't looked at very much. A very big one for explicitly remapping PGs. This is really, really exciting because it lets you, on a per pool basis, be able to say that a distribution looks bad or doesn't look optimal. And after the PGs have already been mapped for that pool, you can go in and say, okay, now I want to remap these PGs in some kind of user specified way. And there's a little script, I think, that Sage wrote that will go through and actually look at how poorly distributed the pool is, the PGs in the pool are, and then basically rebalance them so that you have a perfectly even distribution. So really, really exciting. This is something we've needed something like this for a long time. I had kind of been thinking something different along lines of making it so that you could have different crush buckets kind of occupy a place in multiple hierarchies at the same time, which I think could have accomplished something like this. But frankly, I think Sage's solution is probably easier and nicer in a lot of ways. So yeah, it's very, very exciting. What else here? Apparently, we had forgotten to set the min-alloc size SSD in Blue Store to 16 KB. We thought we had done that actually last fall, but apparently we had forgotten to or something. So we just did that now. It might be that we can reduce that down to 8 KB or 4 KB as we reduce the metadata load in RocksDB, or if we switch over to something else like Metascale. But at least for the moment, we're bumping that to 16 KB just because there's too much metadata, both in memory and in RocksDB otherwise. Let's see. There's been a lot of discussion on this one from Radislav for extent map encode sum. I think Igor's been doing a lot of review on that. I have to admit I haven't actually looked at it really closely yet. The fixed deferred rights PR merged last night. In some cases, it seems to be maybe improving performance a little bit, but in other cases, it might actually be a little bit slower. That does also fix a whole bunch of issues apparently that we had that Sage noticed once he started looking into it. So it's definitely needed. We probably should try to understand why the performance is not universally better. So we'll probably look into that a little bit more. And then this RCU locking one, that was by Dan Lambright a while back. It turns out that it actually doesn't appear to be very much faster or any faster than our current locking mechanism. And that actually has all been moved out of the hot path now, from what I understand. So it might not really matter in the end anyway. There was a note in the PR that some folks are trying to resurrect some code that the cohort FS guys had for instrumenting the OSD to get like benchmark or latency stats out of certain parts of the code. So that would be a nice effort. If that happens, then we could at least try to start better understanding where we're spending time here. The LTTNG work also might kind of provide the same thing, but I haven't heard much about what's going on with that these days. So anyway,
I think it was 2 parts. One part is to, like you were saying, part of our idea was to introduce a whole lot of LTTNG tracing into the OSD, and then also to have the direct messenger / memstore thing, so we could basically just have the OSD top half more or less by itself without confounding variables, and then just focus on finding latency in those areas where it was on the top rather than the bottom, more or less.
Oh, fantastic! Yeah, that's great. I think, at least in my opinion, we've kind of needed to do that kind of thing for a long time and separate out the code as much as possible so we can just do micro benchmarks like this. But very good. Any idea if that's, Adam, do you think that's going to happen anytime soon, or is it kind of?
So it is in our interest. Like right now, we're working on trying to finish up a bunch of RGW related stuff, but we are going to be trying to move into improving RGW performance, and I think we want to try to focus on improving OSD performance as a means to improve RGW performance.
Yes.
As sort of something that is very, like, we aren't starting it right now. We've been thinking about it, but we're sort of hoping to reallocate people and push on that effort when we can.
Yeah, that's
probably sometime after Luminous drops, I would guess.
Honestly, that in my opinion, that was kind of the big reason for Blue Store's all these things that we look at when we look at RBD or RG, especially RGW performance, a lot of it leads back to the OSD. So yeah, I think you're on the right track there.
Guys, if I may interrupt, in the matter of Rados Gateway performance, I guess we can I personally think that Rados Gateway is a type of guy that simply orchestrates data transfers between two file descriptors. One file descriptor is the one related to Rados, to the Rados layer, to OSDs, to OSD and OSD. The second one is for HTTP client. At the moment, we are doing a lot of memory copy there, a lot of bulk memory copy, and maybe we could avoid that. Adam Kupczyk some time ago made a pull request bringing buffer Ceph buffer row implementation built on top of standard Linux zero copy facilities. I mean here the pipe and calls like splice and T. This is quite funny because today, at this moment, we are writing a proposal to Ceph Devel about extending the interface of buffer list to get even more savings during the management of data transfers. I think that this might be quite interesting. In many situations, Rados Gateway tends to move a lot of data. Maybe copying them, maybe pulling those data from kernel only to pull it back. Maybe we could try to avoid that.
I think it's a very interesting idea. I'd certainly like to see it. I know the parts that I've been thinking. I know the parts that I had been wanting to look at the most myself is that since I'm aware of a bunch of inefficiencies, allocation, just sort of, having very large critical sections where a bunch of stuff happens in the OSD client. I was also hoping to both improve the implementation there and come up with sort of a variant interface that would be a bit more, be a bit less allocatey, basically, for lack of a better word. But
Sure.
yeah,
Eradication of dynamic memory allocations, dynalogs.
yes.
Some time ago, there was even another initiative related to that, static pointer. Actually, it's I would say it's the code is there, it's in place, but we would need to start even thinking of productization. This concept, we would need to write a lot of unit tests.
Well, so I can actually think of actually have a bunch of unit tests for something similar, but for a different purpose and a different project. But static pointer is an interesting idea, and it works very well for polymorphism in things like the allocator case. For most of the stuff I was thinking about in the OSD client interface per se, I don't think that we actually have the kind of polymorphism that would make that would necessarily require that, or at least I don't recall any. But it does make a lot of sense in some of the other parts of RGW that I'm aware of.
Okay, got it.
But I would certainly be happy at some point to help trying to get static pointer production ready.
Yeah, might be interesting, but at the moment we are loaded with a lot of different cases.
Yes.
So even with all of that work, and I do think that's going to be really good, especially since it seems like we just burn through CPU in RGW to do anything. The other things that at least that I've been seeing that more kind of point to the OSD side is the time spent in bucket index updates that specifically kind of relates to how quickly we can do OMAP reads and writes, and then also more file store specific related, although that's also kind of a file store issue, but the way that we split PGs and the number of objects that gets created, especially if you look at something like erasure coding with RGW, where you have lots and lots of chunks that get created potentially with smaller objects in RGW. It's really nasty.
Do either of those persist in the brave new world of BlueStore? Because I sort of gotten the impression that we didn't really want to, at least from other episodes of the Ceph performance call, that we didn't want to spend too much time working on file store specific stuff. I mean, if we do, that's fine. Cool. I just thought we were.
Yeah, no, we're not. Yeah, we're not fixing either of those in file store, to be honest. In BlueStore, those issues are not nearly as bad. Well, I should rephrase that. In BlueStore, some of those issues basically just go away, specifically like the PG splitting issue, but we do inherit new ones. Specifically, as the amount of metadata in RocksDB increases, you have a lot of compaction overhead. And so we'll just need to be mindful of the fact that potentially you might have, if you've got lots of OMAP going on, RocksDB could start becoming a problem. And in general, if you have lots of objects and lots of extents and other things, you potentially could have RocksDB again becoming kind of a bottleneck. So that's, in my mind, all the work that's going on with trying to reduce the amount of metadata Blue Store. Anything that we can do to reduce the metadata size. And I know Igor's been working on it. I know Radoslav has been working on that. And folks from SanDisk have been working on that too. That's all a very, very good effort. I think we will see the benefit from that, both in terms of like small random RBD writes, and then also as you get lots and lots of RGW objects, I think we're going to see that pay off. But anyway, that's my take on it.
So from what you're saying, it sounds like anything that makes a whole lot of heavy OMAP use could sort of degrade the performance of all aspects of Blue Store just by forcing these sorts of compactions?
I think so. I suspect that will be the case.
Because I know one thing that Matt had been talking about was wanting to try to partition out either very, very large sets of OMAP prefix keys or something like that into a database. I don't know how that would handle consistency, or if there was some way that we could sort of hint it to have to basically sort of have multiple compaction domains, perhaps. I'm not an expert on RocksDB.
What so what you're kind of talking about are column families, where basically you share a write-ahead log, but then you split it off into like separate SSTs essentially for each domain that you have. And we did play around with that a little bit. There was actually a PR where we were doing it and it worked. I don't know why we ended up never really merging it, but that's totally doable. And it might be that actually does help us in the long run, especially in situations like you just mentioned where we've got like tons of OMAP traffic.
Yeah, because it sounds like, I'd have to look at the key schema, but it sounds like if there were actually some way that somewhere in the OSD or in the method calls that we have there, it sounds like if we could have some sort of hinting to be able to create a column family for a part of key space that we expect to come with to be a large bucket index, say, that might actually be good. So we could have different bucket indices or a bucket index and the general Blue Store metadata not interfere with each other.
Yeah. That will probably, I would think, will help with the locking issues, because from what I understand, in RocksDB, you still are only have a single thread for level 0 compactions, but then all of your other like level 1, level 2, whatever compactions can happen in other threads. I don't know when you have column families. I think, but I don't really know, that then you have separate level 0 compaction threads for each column family. So I think you're better off in that way. But the other big thing that we see is just that you have so much write amp in general with RocksDB that you pretty quickly overwhelm the device you're on, at least during those compaction cycles. So it might end up being that's the biggest limitation is, well, write amp and read amp, but you're just kind of hammering the device. That's kind of why like the SanDisk guys were so vigorously looking at trying to get Zetascale working, just because you're not doing that kind of compaction anymore.
Is Zetascale another KV database, or?
Yes, B-tree based, if I remember right.
All right, thank you.
Yep. So yeah. Anyway, lots and lots of stuff. So what else is on here? I think there are a couple other things in here that I guess I don't know too much about. This CRC32C for PPC architectures. It looks like Kipu reviewed that. And then Sage is now testing this ARM range keys operator interface for RocksDB, which hopefully is better. I seem to remember. I don't really remember, I guess, but RocksDB has kind of some weirdnesses regarding some of these interfaces where they're slower than they should be. So either this is faster than the alternative or it's slower than the alternative, and I don't remember why. But anyway, yeah, I guess Sage is testing that now. All right, so I think that's it for pull requests. It looks like Piotr answered James' question here in the chat about where Sage's PG remapping work is. And yeah, that's to me at least, that's super exciting. This is something that we've needed a solution for years, and it ended up being way simpler than I guess any of us ever realized. So yeah, it's pretty amazing. I was hoping Sage would be able to join to talk about it, but yeah, he's not able to make it because of the vault. But let's see. The other thing I guess I was hoping we could maybe get Sage here for would be to talk about the deferred write changes. I did go through, and I think I mentioned I tested that, and it's not really doing quite what we maybe hoped we'd get out of it. But more testing to do on that. I think that's basically all I have this week. Would anyone else like to jump in with anything?
One thing, basically touching the same area we was talking about last week. The data structures we are using in Bluestar. We had some discussion basically related to sequential structures requiring extended some copy operation, some memory moving on writes, versus dynamic structures like red, black tree, and similar stuff we have at the moment. I was looking for some benchmarks and found very interesting page. Guys, just take a look on that. I already I already forwarded the link to Sage and also posted on Friday's Bluestar meeting. But I guess it could be interesting for a broader audience. What is interesting is that using sequential memory copy based data structures for handling small data structures, for handling small data items like 24 bytes, like our extent instance, might be faster even on random insert. That's terribly interesting, I think. There is a good.
I don't see any graphs.
Yes, I know. The page is pretty old. Unfortunately, to the script, I guess that the script responsible for making those graphs is located outside the HTTPS domain. So we will need to allow your browser to get content from untrusted source. I have in my Chrome, I have a small icon on the right of address bar. This page is trying to load scripts from unauthenticated source. Load unsafe script. After that, it.
Yep, you're right. That fixed it.
Guys, please take a look, especially on random inserts. This is terribly interesting.
Let's see. Wow.
For small items, there is nothing better than that simple, really stupid structure preserving memory continuity.
Yep.
This is because nowadays CPUs, because nowadays CPUs are all about cheating. Main memory is slow, so you have multiple levels of caches. You have protected mode that requires a lot of data translations, a lot of page walking. But you have TLBs, instruction TLB, data TLB, shared TLB, and another stuff. All about cheating. Unfortunately, when someone is using dynamic structures that scatters data around wall memory, you are avoid. For example, prefetchers disable themselves, and you are alone with you are losing cache assistance. You are alone with the terribly slow main memory. I guess that's the case of encode sum. I was speaking with it for some time, and without exchanging data structures, I think that the most of the overhead we actually have after the encode sum patch, after the encode sum pull request, is related directly to data structures, to the memory arrangement of data. We are spending more. We have around of misses on L3. I think that simply data prefetchers at this level simply disabled themselves because they observed a pattern in accessing memory that they consider as a random one. I know that also Adam Kupczyk is working on decode path on reads and observed similar behavior.
Yeah, I can corroborate to this this way that I took the previous Radek patch for encode sum, and I tried. He introduced some kind of slap allocators related to each O node, so they were kept together. I tried to play with that and make one big slap allocator for entire blue store, and that caused it to locate extents in a definitely random places after some time, and I've seen degradation in performance tenfold. So I guess I will follow that lead, that we have a problem when we don't have a continuous sequential access to memory on data structures.
Yeah. Yep. Okay.
Guys, this is especially true in the case of extent map T. Extent map T is a type def over boost intrusive set. Boost intrusive set is based on red-black trees, and we are using this very powerful machinery to handle just 24 bytes long data structure, including the padding between members.
Yep.
I would say that switching to something really stupid with terrible theoretical complexity could be a better way than using those fine algorithms of balanced trees.
I think it's at least worth trying.
We plan to take care of that. At the moment, I'm finishing the authentication rework in Rados Gateway. I promised to Matt, I promised to Yehuda that I will take care of that, and I'm almost done with it. We'll switch back to Bluester very, very soon.
Okay, cool. One thing I maybe since you guys are digging into some, looking at this really closely right now, what do you think the possibility is for being able to encode multiple required values at once so that we can start doing some encode decode? That's something that's been bugging me for a long time.
Very, very good idea, but this means we would need to also to change the serialization format we have right now. But this shouldn't be a problem. We can just simply bump a version by one and preserve current code for the legacy path.
Yeah.
We can try. The idea is to serialize blobs first, then extents, then mapping between them. I guess in such situation, yeah, I guess quite reasonable idea.
If we do that, not only can we do SIMD, but then we can also use better encode decode formats than Variant that get you is both lower CPU overhead and slightly better encoding. So yeah.
Well, I actually tested the performance of our variant encoding, and I was surprised that when we have huge amount of variants to decode, I actually first made a testing batch by logging all the variants that were decoded by BlueStore during a test, and I extracted 45 million of variants into the file that was 100 megabytes. And on my not very powerful machine, they all decoded in 200 milliseconds. So I'm not really sure that when we have them decode sequential and we just reuse all the machine caches and that kinds of things, then we will have to remake the variant decoding. I mean, I tested decoding, not encoding, so maybe encoding is broken, but decoding was fine.
Okay. That's you did 45 million in 200 milliseconds?
Yeah, yes.
Wow.
45 million in 200 milliseconds.
Huh.
Actually, I could, I think, share that test because I made it a part of a test in unit test DNC. I guess that was that.
Okay.
Adam, have you got a chance to run those tests under perf? I would guess I would love to take a look on the IPC factor coming from there. I suppose it's much more than 1, maybe 3 or even more.
Well, no, I didn't, but I can when I switch to real machine because I made it on my laptop. So there's no perf. Yep.
No PMU access from virtual machine. Yep. But I guess, guys, I think nowadays machines, nowadays CPUs are really powerful beasts. They are able to execute many instructions. They are superscalar. They are able to execute many instructions per cycle. All you need to do is to feed them with data, and dynamic structures are bad in that matter.
Mm-hmm.
Adam, are you had you in your test? Are the data, is the data continuous in memory?
Yes, I'm reading from one huge buffer pointer.
Okay, got it.
Yeah. Okay. Interesting. Well, Radoslav, yeah, I don't disagree with anything you said. It all seems very reasonable to me if we can make it work.
I hope so. But at the moment, that is only a theory. We definitely want to have code, to have change sets, and verify them in practice.
Yeah, and I won't speak for Sage, I guess, but there's always the concern too that it is much more difficult to follow what's going on, right? Right now we have all these things in memory that that sort of make sense, and a lot of the things that we're talking about mean that potentially, maybe not, but potentially maybe it could be a little bit harder to understand what's going on. Are you muted? I'm not sure if you were going to say something.
Radek said, "Sure."
Okay.
Sorry, I was muted. Sorry.
No worries. All right. Well, does anyone have any other things that they'd like to talk about this week? I don't see Nick on. I was going to see if he had any updates for us, but probably not. All right. Well then, have a good week, guys, and hopefully next week we'll have the multi-KV sync thread stuff worked out, or at least split KV sync thread rather, and we can get some feedback on that. And then Radoslav, I did I think I mentioned to you I did some testing on your bitmap allocator work, and it definitely is improving things. So I'd like to see us get that merged and then also get that tested also with Igor's split KB sync thread stuff, and just kind of see where we land and where we're at, and then hopefully get some more perf results at that point to get a better understanding of kind of what the lay of the land looks like.
Cool. We haven't finished with the memory allocator yet. We definitely want to preserve allocation schemes and also make the internal structures, at least at the bottom layers, which are very, very populated with data. We want to have those data continuous in memory, because right now we are jumping from area to area to just take a look whether the place is empty or not.
Yes. I think that work that you're doing on the bitmap allocator has been very fruitful. So I think continuing to work on that will be good. But so is the encode decode path. So you're hitting all the right areas.
By the way, Mark, there are some controls you can provide. You can feed to system to show or hide some particular costs we have. For example, if you want to test the memory allocator overhead itself without too much costs of traversing data structures in encode decode, then going with small Rados objects is reasonable. Small, I mean here around 4 kilobyte each. However, if you want to expose, if you want to something completely opposite, if you want to expose the overhead of encode decode, encode sum, you can try using small writes 4 kilobyte each across pretty big radius objects like 4 megabyte long. Then the input. There is a shift of importance between those bottlenecks we have at the front end of Bluester's pipeline.
Yeah, and at least from all the testing that I've done, those have been the two things that have always struck out at me is bitmap allocator locking issues, which you jumped right in on, and then also like you said, encode sum. And all of the associated things that come with our metadata overhead, ranging from memory scattered all over the place to just the amount of metadata that we're shoving in RocksDB and how much work RocksDB ends up doing because of it. So yeah, no, you're doing good. keep up the good work.
Thanks. We will.
Very good. All right. Well,
Adam is working right now on quite a small but very fruitful. Adam, just speak for yourself.
Well, actually, I'm trying to squeeze a bit structures in BlueStore, and I made two things. I mean, well, actually three things. It will be pull request soon. One is I changed a bit decoding of variant, and I got rid of checking if we going out of the input buffer with each iteration. So it's just now checked after decoding variant if we somehow did not get additional superfluous bytes, and then we make a throw. We're not trying to throw with any bytes. And all a bit realigned it so it made shorter, but that was a small one. I squeezed out from extent reference to onode, because all the extent maps that we have are always located in onode. So it's possible when you're operating on onode actually locate where you are without that additional pointer, which was a bit confusing for the CPU, I guess, when it operated. So now it just subtracts the bytes and finds where it was. That's the one thing. And the second one, I inserted shard blobs. I made a lazy creation of shard blobs. Now when you create a blob, you just have a blob, and the first time you actually need to do something with shared blob, you create it later. And it made like 8% improvement when a random write test using FIO. So I was satisfied with that.
The first part of what you had just said now about in decode, do I understand correctly? You're saying that you're not. Previously, we were checking every single time you were iterating through the loop. We were checking to make sure that we weren't exceeding the buffer.
Yes, that's the current implementation of decode variant. That with each byte we taken from a input stream, we check if we're not about to make an exception, because we throw an exception if we're trying to read after the last accessible byte.
Oh, yuck. Okay.
And I moved it outside of I mean, the small side effect would be that if for some reason our buffer list was corrupted and ends exactly with page alignment, and we try to read one byte after that corrupted buffer list, then we could, instead of making a throw that we out of data, we could throw a segmentation fault. But it can happen only if you're decoding broken data.
Mm-hmm.
So that's a trade-off that I would like to take note of that, and if that's acceptable, then maybe we can do this. I don't know. I think that we can go with having a segmentation fault instead of throwing exception, especially that we actually don't catch them very much.
Yeah, even if we would catch, I guess that the obvious decision is to just abort the whole program, the whole OSD.
Probably.
So,
yeah.
So having segmentation. Thanks. So having a segmentation fault, especially if we provide a handler for it, like we do at the moment, it's not so bad. I would say it's comparable to just aborting.
Well, actually, it would be easier to debug, because when we try to debug from the catching exception, you are actually nowhere.
Well, let's ultimately we'll run it by Sage and see what he thinks. But yeah.
Sure. Anyway, guys, I think we have two separated items we can work on: write path and read path. At the moment, read path is even read path is not so well optimized, but we don't see it typically because of presence of huge metadata caches. However, in production deployments, having such large caches might not be acceptable. I suppose that in production, people will tend to have many OSDs, even based on NVMe devices on the same node. So I would say that we cannot spend dozens of CPU cores and gigabytes of memory to overcome some issues we have on lower layers. We will need to fix them up.
Well, and to give some numbers, when I tested it, and sum is 10 times faster than decode sum. So if we will get out of the cache zone, we will get strongly degraded.
It's, in other words, it looks that that the right path that we thought is the slowest one, after removing some support from metadata caching at Bluster layer, is faster than the read path.
Interesting. Huh. I wouldn't have expected it, to be honest. Maybe it's because we've been spending
Me
so much
too.
time optimizing the right path. Maybe that's, yeah, crazy. All right, well, yeah. Keep up the good work, guys. It's definitely good to have multiple eyes on this kind of thing.
Sure, we will do.
All right. Well, I would say then that unless anyone else has any last minute things they want to bring up, let's wrap this up and reconvene next week. Anyone? All right. Well, have a good week, everyone. Talk to you later.
Thanks. The same for you. Bye, guys.
Bye, guys.
See ya.